Okay, I'm going to be doing problem 18. A rectangular block of copper has sides of length 10 centimeters, 20 centimeters, and 40 centimeters. If the block is connected to a 6-volt source across two of its opposite faces, what are A, the maximum current, and B, the minimum current that the block can carry? Okay, so we're given that the block has lengths of 0.1 meters, 0.2 meters, and 0.4 meters. The voltage is 6 volts. And so in part A, we're being asked what is the maximum current. So the maximum current is I is V over R. And for us to have the maximum current, we need the minimum R we can get. So the lowest value of R possible will give us the maximum current. So we need to solve for the minimum R value. So the minimum R is equal to the resistivity times length over area. We're given that this wire is copper, so we know its resistivity is going to be 1.7 times 10 to the negative 8 ohm meters. And the length of the copper wire, for us to have the minimum resistivity, we need the lowest length possible, and we need the highest area possible. So for us to have the lowest length possible, it's going to be 0.1 meters. And then the highest area possible is going to be 0.2 meters times 0.4 meters, which is 0.08 meters squared. So we just plug those values in. So lowest length, 0.1 meters. And then highest area is 0.2 times 0.4 meters, so that is 0.08 meters squared. So the minimum resistance is, when we enter this into our calculator, it's going to be 2.125 times 10 to the negative 8 ohms. So now we find the current at this minimum resistance, which is going to be 6 volts over 2.125 times 10 to the negative 8 ohms. And when we enter this into our calculator, we get the maximum current is 2.82 times 10 to the 8 amps. Alright, so now in part B, it's asking for the minimum current. So I is V over R. So for the minimum current, we need the maximum resistance in the denominator. So it's going to be voltage over maximum resistance. So we need to solve for this maximum resistance. So the max resistance is the resistivity times length over area. So once again, that we know the resistivity is 1.7 times 10 to the negative 8. And so for us to have the maximum resistance, we need the highest length possible divided by the lowest area possible. So the highest length possible is going to be 0.4 meters. And the highest length possible is going to be 0.4 meters, and the lowest area possible is going to be 0.1 meters times 0.2 meters, which is 0.02 meters squared. So we plug in the highest length possible, 0.4 meters, divided by the lowest area possible, which is 0.02 meters squared. And when we enter this into our calculator, our maximum resistance comes out as 3.4 times 10 to the negative 7th ohms. And then when we find the minimum current, it's going to be 6 volts over the 3.4 times 10 to the negative 7th ohms. So our minimum current when we enter this into our calculator is 1.76 times 10 to the 7th amps. Okay, thank you.